so-called levelized cost of electricity was the main performance indicator of the photovoltaic system. Introducing the crop changes things dramatically.
It's no secret that the energy transformation and its massive expansion of solar electricity production also comes about with its own challenges. One, if you're particularly talking about ground-mounted PV systems, is obviously the amount of available space. Often, PV actually is in competition with land being used for agriculture. And we all know that agricultural land all around the globe is a very limited and very valuable resource. So obviously, in theory, agrivoltaics, so the double use of land for on the one hand PV and on the other hand agriculture, seems to solve this conflict. And not only would it solve this conflict, it actually would come with a lot of positive upsides. On the one hand, for example, Agri-PV could help to mitigate actually some of the already happening effects of climate change. So it might protect actually crops from the increasing heat they're exposed to. It actually might provide a double income for farmers and thus promote the economic development of rural areas. And of course, it would make best use of a very scarce resource. So how big is the gap between Agri-PV in theory and Agri-PV actually being implemented and all these positive effects coming to fruition? This is what we want to find out in this episode. Welcome to the Smartery podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. I'm very happy to welcome an absolute expert in the topic we have for this episode, Professor Stefano Amaducci. He's a professor for agronomy and field crops at the Department of Sustainable Crop Production at the Catholic University of the Sacred Heart in Piacenza in Italy. And on top of that, he actually happened to be the conference chair of Agrivoltaics 2022, an international conference that just took place in Piacenza. So not only does he come with all of his own research into this conversation, but he also comes with all the fresh impressions and learnings he took away from talking to all of his international colleagues worldwide. Very glad to have you on the podcast. Welcome, Stefano.
Welcome. Thanks for having me.
In my opening, I already said that actually Agri-PV in theory could be also very relevant in the light of climate change and obviously crops being exposed to higher and higher temperatures. So if you look at it practically, how big of the role is Agri-PV going to be in the light of climate change? Maybe also in combination, for example, of Agri-PV with intelligent irrigation systems. So how big is its role there?
In fact, one of the most, let's say, agreed upon fact about agrivoltaics is that through agrivoltaics, plants tend to use less water and are also less affected by high temperature. And this is because, of course, the shade generated by the panels, of course, reduces both evaporation from the soil of the water. So when you irrigate, you have a higher water use efficiency, and also transpiration from the plant. And this, of course, puts together, reduces the overall amount of water that the crop uses to produce a unit of product. Usually, also when we talk about the water footprint of a crop, we say how many liters of water we have consumed to produce a kilo of wheat or a kilo of any other product. And this is significantly reduced under agrivoltaics. So in this moment, we are under a very serious pressure because we have no water in the north of Italy. It's kind of unprecedented. Still in June, to see that the Po River is very low, and every region in our area has forbidden, the use of water for many normal application, and also is very limited for agriculture. And really, there is June, July, and August ahead, and we don't know how it will end this year. And this is something that it's happening more and more frequently because of climate change, and any type of technology that can reduce the use of water is very welcome, or even to mitigate, the absence of water or the high temperature. So this is, I think, a very interesting aspect. So both mitigation and adaptation are addressed by Agri-PV.
I was just going to say that while we speak, really, you have a very a severe situation in Italy in regards to the River Po, for example, drying out. Now, you address specifically evaporation. Is there also a combination of intelligent irrigation systems where you can also use the electricity of the PV right away to control sort of the flow of water through the fields? Or is it something that does happen independently of PV anyways?
Well, it can happen also independently, but I think that besides being a technology which fits perfectly in all the problematics linked to climate change, agrivoltaics also fit into one of the other very important technology of the moment in the sector of agriculture and in production in general, which is what we call intelligent agriculture, precision agriculture, or agriculture 4.0, so the connected agriculture. For all of this, you need, of course, energy, and it can be linked to irrigation. So, for example, water is pumped, especially in certain type of irrigation system. You have to have high pressure water, so you need a lot of energy, and this energy, of course, can be electricity. But this is also an application that we already have in agriculture, and not necessarily is linked to agrivoltaics, but also simply to photovoltaics. So it's the link in between photovoltaics and agriculture. But of course, it can be reinforced by agrivoltaics. Then there is also the possibility that the use of electricity will be more pervasive in agriculture, as it is already in perspective in the automotive sectors with electric cars. So we can think about electric tractors, for example, and maybe even systems that are charged or powered directly, because you can imagine that you have always, the electricity nearby with agrivoltaics, and so it will be big tractor or maybe small machineries, to cut the grass, for example, or to take care of the crops, or, as you were mentioning, to irrigate. All these are ideas that are, I would say, in their infancy, but we are already talking about and thinking how to better integrate the use of electric energy and agriculture under an agrivoltaic system.
Right, I see. So it's a whole span there. If I just sum up already what I took away there, it's, of course, Agri-PV provides more shade, so it blocks evaporation to a certain extent, and then you could make use of the energy being produced on the ground in various Agri 4.0, as you put it, schemes. So either to power an electric energy storage on the ground that then for example recharges the tractor or other machinery. You can power irrigation. I think now it comes to my mind at the Smart RE in Munich, for example, there was one example where they use that specifically in India, in remote areas where there's no electricity grid, and they usually use diesel pumps or diesel generators for their pumps. So I guess in these regions that even makes even more sense than in Italy, where probably you have an electric cable already next to the field. So that's quite interesting. Just before I move on to the next question, you say theoretically, how far are we between it's being in its infancy right now to such schemes being implemented on a large scale?
Well, I mean, I think that in general, agrivoltaics can be considered in its infancy. It's just like, I would say, a few years. I mean, the Agrivoltaics 2022 was a conference that has just happened and was the third edition. So it's the first conference, it's just like 3 years old, which, let's say, gather all the researchers that internationally work on agrivoltaics. Specifically, I was referring to the use of electricity in agriculture, and this is even something I would see more for the future. But referring specifically to the agrivoltaic technologies, I think that we are at tier L9, so we are commercial, with many companies that provide a wide array, I would say, of solution, which span from the more traditional photovoltaics, ground-based photovoltaic systems, to the more high mounted panels with single or double axis technologies, so with different level of complications, of course, economic cost, but also possibility to really manage the photovoltaic system in integration with the agricultural management, which I think this is what is, I think personally, I find more interesting. Just to answer your question, I would say that the first large agrivoltaics plants are in the field. And actually in my region, and this is actually why I am working on agrivoltaics, there are 3 agrivoltaics fields, which are all of 3 larger than 10 hectares. So I would say a quite large surface, and they have been running for over 11 years. So this was something that we showed also during the conference as a field visit, and everybody was kind of shocked to see this development that was already performed 11 years ago.
So quite visionary. And what's interesting also is the durability. I mean, running for 11 years already is quite something. So that gives you already proof how durable this is, right next to machinery being operated, etc., being higher off the ground, etc. That's quite interesting. So now I understand there's obviously 2 different timelines. One is like just mounting PV higher up on a field for electricity production and maybe feeding it into the grid. That's obviously doable much faster. And then it being part of the electrification of agriculture might take a little bit longer because of course it depends on electric tractors being available, being bought, etc. Now, I mentioned also in the intro that maybe Agri-PV can make a contribution to the conflict between land being used either for agriculture or for electricity generation. So how big is its role there? How big is the potential of bringing those 2 competing use cases together?
Well, I think that the first time that agrivoltaics was actually conceived was really conceived for this potential role that it would have. So in the 80s, in front of the exponential development of photovoltaics, of course it was clear that it was not enough to just put photovoltaics panel on our roofs to satisfy our energy demand and the growing energy demand. So the necessity to place photovoltaics on the field was clear from the beginning. So why not to combine agricultural activities, which are the main use or the most common use of land we have on the planet, with the production of photovoltaics. So I think that this was the main reason for actually conceiving agrivoltaics. And now that we are studying, we see that we could have like a great advantage. And in fact, and I think this is one of the most important to consider in the study and in the development of agrivoltaics, is what key performance indicators to use to optimize and to develop the technology, because the photovoltaic technology is very well optimized. We have like 30 years of experience of optimizing the design of agrivoltaics, and this has always been done with the objective of reducing the cost of electricity. So the so-called levelized cost of electricity was the main performance indicator of the photovoltaic system. Introducing the crop changes things dramatically, because of course the income deriving from the energy production from photovoltaics by far exceeds, in most of the cases, the income coming from the production of farming activities. So you cannot use the same parameter. So one of the parameters that we use now is, for example, is an ecological indicator, which is the land equivalent ratio. So it's I don't get into many details, but it's an indicator that provides evidence that you use better the land if you have a high value of this indicator, which comes from the fact that if you separate, so for example, you have ground-based photovoltaics on one field and the crops on the other field, and you sum your production, you reach a value. If you combine the two things in the same field, this value can increase. And if it's higher with the combination of the two, it means that you have a positive interaction in between the production of electricity and food. So this is one new metric that you have to consider, but there has to be more metrics. So for example, social acceptance. So all these metrics that can help us to design a more successful, sustainable and durable agrivoltaic technology.
Now, if I hear this, that which seems to be obvious, that mounting PV on your field is just much more profitable as a farmer, and I can imagine, farmer thinking like, why should I go for the Agri-PV at all? If already PV is big enough of a profit, I can just lean back and enjoy my life. So that to me sounds like there probably needs to be a regulatory incentive for farmers to actually go for the agriculture as well. So is it a question of regulatory incentive to go for a very big land use ratio, as you put it?
Well, I think that there is a very important political decision that has to be taken at this level. So you said a farmer would prefer to lay back and get the easy money from the photovoltaics, but then it is no longer a farmer. And I think that what we ask to the farmer is, first of all, to produce food, which is our primary need, and to also be a steward of the environment. And in the moment that you give up on these two roles to get a new role, which is like energy producer, then you're of course changing totally the way you use the soil. And I think that, I work as an agronomist, especially in field crops, and I always worked actually also from a research point of view with biomass crops. So to use the land to produce crops and then are used to produce electricity. And we all know the food fuel dilemma or debate. So to produce energy and fuel out of land, even out of crops, while of course we are still deficient on the planet for food, and the food has to increase, and the land is limited. So the nexus food, energy, and to that we usually add the one of water use, which is also important for the energy production. It's really at the core of the strategic decision and at the base of all the research questions we have around agrivoltaics. So to answer your question, I would say the farmer should keep doing farming, and this is out of question. And I think a good farmer would never give up his activity just to sit back and change job, because that is something that normally a farmer wouldn't do. But of course, I think we shouldn't let the decision be taken freely. I think we have to protect our capacity to produce food. And in this moment, it's not just a moment of drought, but it's also a moment of, I think we are about to face probably also a food problem because of the lack of cereals linked to the war in this moment. So we are back, energy and food are two key issues on the political agenda, and I think we should not give up on one for the others, especially the land is mainly for food.
That's true. As we speak, of course, it's quite obvious that in the next month we'll also be facing a huge crisis in regards to enough crops being available, specifically for the global south due to the war in Ukraine and Russia's attack there. But to me, that's quite an important takeaway, is that it's not only an innovation challenge in the sense of making it possible, electrifying agriculture, it is also a regulatory challenge, because you cannot just simply trust in farmers loving farming so much that they will continue to do it, but you really need a legal framework that probably really demands the agricultural use of the land at the same time. Since we already talked about crops there, are there any specific crops and climate conditions that go particularly well for Agri-PV? Maybe you can dive a little bit into that, what your so far your experience is, and maybe also what your estimation is for the years to come. Which crops work well, which regions work well, hot or cold climates? Is there the potential to it really being a global approach, or will it be more like dependent on certain regions? What's the scenario there?
Well, this is at the core of my research activity. Of course, I'm an agronomist, so I deal with crop, and I immediately was challenged by agrivoltaics, which I think that maybe the listener already identify as a complex problem, the one of agrivoltaics. Putting together agronomists with electric engineer, it's a challenge. It's different. The industrial world of producing electricity and the farming world of producing food, and especially if you go at the physiological level of the plant. So we know, for example, that the plant needs energy for the photosynthesis, so for producing biomass, but in many conditions there is an exceeding amount of energy compared to what are the needs of the crop. So there is also energy that can be used for electricity, but to balance the need of the crop with the actual presence of energy, and at the same time maybe orientate the panels according to not only following the sun, as the panels always do, to maximize energy production, but maybe to turn away from the sun to let more radiation arrive to the crop in specific moments where we know that the crop needs light, maybe to start a fruit setting or to have more flowers. And so there are specific moments in the development and the cycle of the crop in which there are specific needs, which are then, of course, linked to the final yield. And we have a good knowledge of these things, but we haven't really, so much experience in changing the light environments. Usually we do, but in controlled conditions, like in greenhouses, where we can even play with the wavelength. But in the full field, and especially in certain type of crops that are grown in open field, like the field crops, we still have to gain a lot of knowledge on that. To answer your question, then I think that there will be no one single solution to the agrivoltaic problems in terms of cultivation. So, as it is in farming activities, every region, every environment, every soil will have its specific crops. Actually, crop rotation, because especially if you use annual crops, you need to put them in rotation, and also agronomic techniques. And this, I think, it's a very important paradigmatic shift.
So that does sound indeed a lot more complex. I know, for example, there's a lot of AI already being promoted in the use just for the operation of PV plants, but I assume that really makes Agri 4.0, as you said, or Agriculture 4.0 so much more relevant, because to then on top add something that's so much more complex as farming, that's so much more, as you said, depends on specific times of the year. The crop needs specific things depending on whether it's a crop in Asia, in Europe, in Italy, or maybe in Scandinavia. And then it really becomes complex. I guess you need to pair a lot of data with the steering of the PV, and I assume that on the future, hopefully that's something that AI will solve. But going into that very specifically, for example, typical crops in Europe, what would that be? And are they compatible with Agri-PV versus, for example, I imagine, in Asia, rice being produced a lot, or soy. So are these typical crops that you have throughout the regions, are they compatible with Agri-PV? If you can just give us an example for Asia, for Europe, for the Americas or South America.
I didn't want to evade your question before when you asked which are the crops that can be used under agrivoltaics. So I give you some information about that. First of all, I think that everybody would point to crops that can be grown, or plants that can be grown in shaded environments. So, for example, lettuce. And the first studies on agrivoltaics really started on lettuce, because our crop that everybody knows, if you grow in full sun during summer, they don't actually grow, so you have to shade them. And this is a classical example. Or, for example, soft fruit, berries, which are typically grown, they grow spontaneous in the high mountains or in the wood. Other crops which are studied are also trees. So recently there are studies on pears or grapes, for example. Grapes is interesting because we know very well the physiology of grapes. So, for example, when it needs more and when it needs less light. So this is also another option. I personally also studied other horticultural crops like potatoes, tomatoes, and also normal field crops like wheat, for example, or rice or maize. And of course, we are gaining this knowledge which can be used to optimize and to co-optimize. So it's not just thinking which is the best crop to put under the panel, but we also have to design agrivoltaic systems. So to define in a certain environment, which is the amount of panels that we can have for the crops that can be grown in this environment. So this is the type of optimization. It's not an easy process, also because usually in agronomy, we have to make trials. So you see which is the effect of any kind of treatment. In this case, is shade on crops. And we repeat these experiments many years because every year is different, every soil is different, every climate. So you can imagine that a lot of time would be necessary to have all the data necessary to create this optimization. And this is why now most of the research focus on modeling. So the use of mathematical models that are very well used for simulating how changing the configuration of a photovoltaic plant affects energy production, but also, on the other hand, on the crops. So we have crop growth models that we use normally to forecast yield, and also the morphology is a little bit more difficult, maybe the quality of the agricultural products, changing what we usually do, irrigation, fertilization, and these kind of things, harvesting time and so on. But in this case, the presence of shade during the course of the cultivation.
That sounds quite interesting. I guess there we come back to the Agri 4.0 and agriculture becoming smart, using a lot of IT and models into, or making use of models in order to really shortcut this year-long experimentation process. Just to wrap up things, maybe two last questions. The first one being, how big is the people challenge on both ends? The one hand, getting acceptance for not only PV in the landscape, but specifically high-mounted PV in the landscape. I mean, specifically in Germany already, setting up wind turbines is a huge problem. I guess people on the countryside are very hesitant on seeing a lot of highly elevated PV in their landscape. And the other people challenge being, how challenging is it to get the actual farmers on board? So are those two human aspects in Agri-PV a big threshold?
Yeah, absolutely. I think that social acceptance is one of the key factors in most of the technology regarding energy, not only photovoltaics, but especially in agrivoltaics, because it touches many key issues. Like I said, food production is primary. So the fear is that if we let agrivoltaics can become a sort of way to continue to do as we did in a massive way 10 years ago with ground-based photovoltaics, where there is actually land stolen from agriculture, so it's seen as a loss of land. The other is the impact on the landscape, so not on the environment, but our perception of the environment. And this is another key issue, which actually was at the center of the conference. At the Agrivoltaic conference, which has just ended, we have had a special session on the landscape integration. So to collect different knowledge at different level. So, for example, architects or landscape specialists to provide solutions. And that was very interesting, actually, because as you said, to have something which is high, it's more difficult to hide. And when we have like photovoltaics, usually we have this mitigation. So we put like trees around, just to cover it up. Maybe we have also to change a little bit our perspective on the landscape, and there is a lot of studies in this sense. So we have somehow to accept that we have to produce energy, and landscape is something which changes, and also our perception. So the energy scapes are all around us. We use energy, then we have poles. So poles can be also an interference in a natural landscape, and nothing is really natural anymore. It's a very complex aspect which fascinates me a lot. I also have collaboration with architects on this, and in particular, I don't know, maybe you can provide the link somehow to the podcast, to the project that won the award that was given during the conference. It was a student award to the best, let's say, interpretation of the agrivoltaics plant that we will build on campus. So we will have just in our campus 1 hectare, so it's a significant size, I would say, an agrivoltaic high. So it's like 5 or 6 meters from the soil, where we'll, of course, carry out our experiments, but we will also grow foods for the canteen, for the students. We will have like social gardens and different activities. And the experience is that if you make people participate, in a participatory approach to the development of the concept, of course, it will be a win-win for everybody, because you will see that you can still grow food, you produce clean energy, and actually maybe it's not so ugly.
Wow, that's been really interesting, Stefano. It's much more complex than I imagined before going into this interview. I really understood now that Agri-PV is not only about combining PV as we know it, like, for example, with a PPA for distributed power production, but with agriculture, but it is really about creating agriculture 4.0. It's much more challenging. You also highlighted that a PV plant that is already very sophisticated in its adjustment to the sun radiation levels now needs to be adjusted specifically to the demands of the crop, which are very different depending on the type of crop, depending on the specific region where it's being planted. So that's something where really modeling comes into play. Already took away, a lot more research needs to be done, and on the long run this is not only dual use of land, so to create energy and to create crops, and on the other hand in electrifying agriculture. So I think the deeper we dive into it, the more relevant it became to me. And it's so interesting that in the whole PV discussion, it is not one of the dominating topics, because now listening to you, it really should be, I feel like. So I hope we will be talking more and more about Agri-PV also here in this podcast. It does have a very crucial role to play, I feel. Thanks a lot, Stefano, for all these insights.
You're welcome. It was a pleasure.
The latest developments and trends in Agri-PV can be found at Intersolar Europe, the world's leading exhibition for the solar industry. Information about the exhibition, the conference, and the latest news, market graphics and studies can be found online at intersolar.de.